Hello data points. So today we are doing our research paper analysis. So in this research we are in this today video we are discussing about the autonumeric AI autonomous PDE multi-agent pipeline and computation, how this is useful for our work and how this is helpful. So let's get started. So first of all, what is the PDE? The PDE is the partial differential equation. So what is the partial differential equation? That simple means in the equation there is the two unknown given and we need to find out the two unknown. So how to find out? If you notice, here is the t, another is the x and t, like that, and here is the sign 2x plus e to the power 2y dy by dx. If you notice, here is the x and in this term here is the y, but we don't have the dy by dx we can calculate. And how we calculate the dx by dy? We have only one part and another part we can calculate through like this. So this is the differential equation, and using this methodology we are implement on the neural network, and through the residual error or the error we can calculate the effectiveness of this code generated. This is found on Google. This is not actual on research papers, so I'm just giving you the idea, like there is how it generate the code, and that uses in the backend the differential equation method. So yeah, so this is only 10-page PDF, so you go through it one by one. So yeah, we done this. Then in that, so let's see what is the problem this research paper solve or try to solve, or giving a perspective to us. The problem is to solve the deep math expertise with manual selection. During this time, we need to manually instruct the LLM. In this paper, we are using the LLM. We are using the for LLM part, while neural network based reduce the manual design. Okay, so yeah. So how this autonumeric generate the code? First is translate the problem, means we are provide in normal format. After that, if you notice in anti-gravity, and the anti-gravity we have the similar type of output, like translate the problem, then planning and filtering it, filter every what needed and plan everything what to plan. So okay, then generate the code, then coarse-to-fine debugging. So what it did, what is coarse? Something rough, undefined, and consisting of large pa particles. Yeah, so it's generate a rough draft, then it's refined, then it generate a rough plan, it refine until it is the self verification. And if it is restarting, it's again start from here. We give the prompt, it's plan, then generate the code, then find and debug itself. Here we are giving the input, then it's plan something. Yes, I have few uh, research. If you click upon one of these, okay, it's need to restart. So yeah, so let's see uh, what are the challenges we are suffer. What are the challenges we are suffer? First, the LLM generate the code often syntax error and logical flaw. And these challenges we suffer from the syntax error, verify the correctness what it is verified. Oh, due to the new update of Google side launch, Google I/O 2026, this logo is also updated, if you notice. And memory issue also happens in our LLM due to the large scale. Due to the large scale, we suffer from the memory issues as well. And what are the solution? High resolution grid. We are using the high resolution grid of neural network and residual based verification mechanism. What is the residual based verification mechanism? If there is any issue, it gives the feedback to itself and that weight is updated. It's give to feedback to this and weight is updated like that. Then history and disseminations mechanism. It means summarize the history and save it itself. Like in Claude Claude coding time, we have one Claude uh, slash summary or something like that. We can slash summary and store in this file, then it store that file in MD format and we can refer it later. So this is the problem and challenges we are suffer. So let's understand the diagram and how it helps us. So what each agent told means, here we have the many agents. So here in this case we have many agents. So first is formulator, planner, feature agent and selector. So what each agent do? Formulator agent which convert the natural language into structure specification, governing equation and create also the boundaries and initial conditions with some parameters. Then planner agent, what it's plan? It simply plan everything. After that, the feature agent, what features build after another, it's analyze this agent. And the selector agent, after done it select one features and do rest things, do the coding. Coder agent generate the initial code. After that it downscale the grid, it's downscale the grid and it's provide to the syntax. Does this syntax is right? If you notice, we need some time to revise or go to the previous step due to the some error. This is the loop. If something is fail, then we generate we again go to the our generate again code initially. If that is success, then we think about the fix the stability. That time what to do, if we are launching one website, then we are go to live test it, and when we are testing it, we have one called code rabbit. It can also find these critical issues for us. After that after that is success, it verify through the error. What are the errors? First is the residue error and the L2 error. uh, if no if fresh start, if nothing happen, log is saved. If we are randomly set create a elephant and in a physically way like that, so it save one log and say that this is not possible for us. Okay. So after final selection and reasoner, it's also provide a reasoning. If we see that, if when the AI complete the code generation, after that at a below it provide us the small summary. What I did, this happens on here, this will provide. I just provide you the theory and practical perspective. So let's go and understand little bit our AI. Our, okay, our so for this also I created one Notion page where you can found this formula. So this is the formula session. U is the generated by AI. U star is the perfect or true answer. This is called elo. This is elo, a mathematical rule for the equation. uh, where is elo? This is the benchmark test. Residual we are done. Course we are done. Then if you notice, this is called yield. This is called yield. This symbols called yield. I also don't know something. I search and I share my notes. If you notice, I create one notes. We already done one video, so that is the second video. So let's started understood this L2 error. L2 error means we already know that in a machine learning, L2 error regularization happens on linear regression with a mean square error, and also we have the L1 error as well. This is the formula. Y actual minus y predict, a summation of total number of prediction of whole squares, like that. Yes. So let's look at the L2. L2 is the total size or average magnitude. This is called epsilon naught. Fractions, it's showing what this means. This simple means that is this 10 to the power minus 12. So first of all, what is L2 error? This is, if you notice, this if you notice, this is the actual, and this is predicted by AI, and this is our actual code, and of magnitude of this we got the difference between AI guesswork and the perfect answer. After, in the bottom syntax, we got the actual answer, means this is the error answer and this is the actual answer. At the below we got our actual answer. Where is the eraser? Yeah. And this is F means, what is the F means? F, it formulate the task of answer. It applies the math of rule and check the result. This means, this residual means, in this case, if our original answer or the true answer is not available, then we can use this answer, and this is the relative implicit answer. When we are using this, such as the conversation law, whereas the force must perfectly balance out of 0, means it is the perfect answer, like that. We can do analyze our code using this. We close this, then we go to some check of, like, code PDE. Code PDE means a simple code generate, means our PDE how much code generate, like that. Then our benchmark is simple, a general benchmark for the AI, a general capability. It's provide the general capability. Then the numeric setting, it shows simples, as the word says, some parameters, like that. Numeric setting direct how the software calculate and stimulate the formula of quantitative data. If you notice, in this we are using this PDE, a multi-agent, for our reduce also the computations work, and the few evaluation metrics using our error, L2 error, implicit error, and residual error. And this is few tables. I also don't know how to read it. In this future, which with the time, I can understood these graphs, and also I can say you what to do, how to read this. So yeah, this is from my side, guys. So meet you in the future next video. So Join. Thank you.